Hello, we're going to do one where you find a hole in a rational function. We know how to find the vertical and the horizontal asymptotes. This is not terribly difficult. It's just something we didn't talk about. So this is the example I'm going to do. It's just like 59 in your homework, only again, the numbers might be a little different. So I'm doing 3 minus 8x minus 3x squared over 3 plus 7x plus 2x squared. So for starters, they just give it to you kind of jumbled up just to mess with you. But the first thing you're going to want to do is factor the top and factor the bottom to see if anything cancels out. And if they're asking you for a whole, then it will. If it doesn't, there's no whole. So I'm just going to rewrite them in our standard form for a quadratic. Negative 3x squared minus 8x plus 3 over 2x squared plus 7x plus 3. Okay, so factor the numerator and the denominator. You would have to factor the denominator anyways to find the vertical asymptotes, but we have to see what the difference is. Okay, so let's just do that. So to factor the top, we never want our x squared term to be negative. So let's factor out that a negative 1 and change it into that. And then we have to factor these two things that both have leading coefficients that are not 1. So that's okay. We know how to do that. So the top has to factor into a 3x and an x, and the bottom has to factor into a 2x and an x. So pick your favorite factoring method. I have to make an 8 out of like a 3 and a negative 1. So I think I have to go plus 3 minus 1, right? Because that gives me 3x squared plus 9x minus 1x. So that's 8x minus 3. And then the bottom, I have to make a 7. So I think if I make so if I have 2x squared plus 6x plus another 1x, that's going to give me a 7x, and that's going to give me 2x plus 1 times x plus 3. So that's the first step. So here's where the hole is. So the hole happens when the numerator and the denominator are both 0. And when I have more time, I'll graph it and show you what it looks like. It's just literally a little hole taken out of the function. So notice, hopefully you notice, we have a common factor on the top and the bottom of x plus 3. So we can technically factor that out, but we have to make a note. So just note that if x equals negative 3, so that factor that we're about to take away would give us like a 0 of when x is negative 3, right? So if x equals negative 3, this top and this bottom, because x plus 3 is going to be 0, is 0 over 0. Okay, so that's the whole. A vertical asymptote happens when the denominator is 0, but the numerator is not. So now we can go ahead and cancel it out. So when we cancel it out, we get this new thing. So it's negative 3x minus 1 over 2x plus 1. Let's just finish the problem. The vertical asymptote happens when the denominator is 0. So we've canceled out everything we need to cancel out, and we found the hole. There can't be any other holes like hiding in there. So the hole comes from the factor you cancel out. So the vertical asymptote is at x equals what? Negative 1/2. So just solve that equation for x. And the horizontal asymptote, remember, it's a totally different process for finding. We could have done that right away. We just look at the original function and say, okay, the leading coefficients are negative 3 and 2. So the horizontal asymptote is going to happen. So I would come all the way back up here to look for the horizontal asymptote. So just, you could have done that right away. So the only numbers that matter here are the leading coefficients of -3 and 2. So it's y equals -3/2. While I've got you, why don't I take a second just to actually graph that? And so we can make sure we're right. So give me 1 second to do that. 3 minus 8x minus 3x squared over 3 plus 7x plus 2x squared. So all the stuff I just said should jibe with whatever's on the graph. But you won't see the whole. So we said there's a vertical asymptote at x is -1/2 and a horizontal asymptote at x is -3/2. So that means when x is -1/2, which it is right here, that's where the function gets split. So the function is really carved up right in the middle when at this imaginary line you're not seeing, but I can make you see it. See, the asymptote splits the graph in half. And then we had a horizontal asymptote at y was -3/2. So that's the horizontal asymptote, is this horizontal black line. Notice if I zoom out, the green function glues itself to the black horizontal line, right? It becomes indistinguishable. Out here, they both look the same. So that's what a horizontal asymptote looks like. We said there was a hole at -3, but you don't see it. And even in your calculator, you wouldn't see it. So you can use the table feature of your calculator to see that. I could try and compute f of -3, and it would give me a because actually f of -3 is undefined. So you're just going to have to take my word for it. That right here at the point -3, -2, there's an invisible hole that you don't see. The function is actually undefined there. It's just like a tiny little pinprick out of it. Okay, I can go over that more in class, but just use the example I just did to do the one that's on the homework, and they're all going to be like this. So once you factor it, the thing that you cancel out gives you the whole.